Good morning, Course 2. This is Investigation 10, and it's Mrs. Elliott working on it. And I just want to say that this is my 5th time to try to do this correctly. So we're all learning that any new skill takes time to learn, and hopefully we'll get better. So what you need for this is going to be some kind of a straight edge or ruler. And you also need to have the compass that I left in on the door in the manila envelope at school. There are still 3 of you that have not picked it up because I checked today. So make sure that you get by to pick up your compass, and I'm going to teach you today how to use this compass since it's a little different than the traditional compass. So starting out on page 699, we have the beginnings of bisecting a segment. Now, what they want you to do is to take a metric ruler, that's the one with the centimeters on it, and they want you to make a 6 centimeter long segment. So coming here is my beginning, and 6 is right here, so I'm going to put my end point here. Now I'm going to take my pen and I'm going to draw a line connecting those two. So there is my 6 centimeter segment. And now what I'm learning to do is to take that segment and cut it into perfect identical segments. So here is my compass. And this compass works a little different. We did learn some of these on Pi Day. Notice the gold ring right here, and there's a hole in the middle of it. So you're going to place that over your end point. Hang on to the clear plastic part. And you want to get a arc going that's going to be slightly bigger than halfway across. So we're just going to kind of guess. So I'm going to start with this 1.5 radius that I see here, knowing that I have to use the exact same one when I make the second arc. So I have to remember I'm using the 1.5. I'm going to use pencil on this part so that you can tell the difference between the lines and the diagrams. It gets kind of confusing when it's all pen. So first thing I'm going to do is make an arc. I go to the other side, place it over the hole. Once again, I put my fingers there. Now this time, the 1.5 is going to be located on the other side of the compass, and I'm going to do an arc again. Now, what you see looks kind of like a fishtail, right? So here is one point where those 2 arcs intersect, and here is the second point where those 2 arcs intersect. Now this should be labeled A, this should be labeled C. Now, these 2 arc lines, I'm going to place my ruler where the intersection of them is. And then I'm going to take my pen and draw a line between them. Now, what I have should be a perpendicular line, which a perpendicular line means that every angle is 90 degrees. So all 4 of these angles are 90 degrees. It also means if I put my ruler up on top of this segment at A, my line should be right at 3 centimeters, which it's pretty much there. And then my line should be at 6, my other endpoint should be at 6 centimeters. So looking in your book, what you've just done is you've constructed. This is a construction. That's what this is called. And you have just constructed a perpendicular bisector. Perpendicular bisector. And we always like to know what words mean. Bi means 2, so it's been split into 2 pieces and they are equal. This right here should be labeled B, this point right where it crosses the line. So now if you look at number 1 question, Use a metric ruler to find AB and BC. So we did AB equaled, the segment AB equaled 3 centimeters. And when I measured segment BC, it also equaled 3 centimeters. That's how we know we bisected it. And then number 2 asks you this question. Where the line and segment intersect, 4 angles are formed. What is the measure of each angle? Well, I kind of gave that away already. Each angle here, since it's a perpendicular bisector, equals how many degrees? 90 degrees. Now, the next question is one of those questions where you have to think about and write out the answer. Why is the line segment you constructed called the perpendicular bisector of the segment? Well, it forms a perpendicular line. It forms a perpendicular line crossing the segment, crossing the original segment, and the line is split in two. It's split into 2 equal lengths. So this AB is exactly the same as BC. Now we're going to also use the perpendicular bisector to help us inscribe a square in a circle. So I am now on page 700. If you want to look there and see what I'm doing. I first have to make a 2-inch circle. So I have to locate a center point, put my gold ring over it, look for the 2-inch radius. Whoops, it looks like they want us to have a 1-inch. Let me see. Draw a dot on your paper to be the center of the circle. Set the distance between the points of your compass to 2 centimeters. Oh, nope, that's not right. Okay, so 2 centimeters. Go to 2 centimeters, and you're going to make a circle with your compass. There you go. You have your complete circle. Now, we have our center point here. So any line that is straight that I draw between the diameter and the outside edge is going to be, this is illustrating, there's the diameter. Now they're going to ask us to identify things sometimes on these points, but this is one point on the diameter, this is another point on the diameter. Now this time, what they would like us to do is to make a perpendicular bisector. So once again, we're going to take our compass, put the gold center over the top of the end point. We can see our diameter this time through here, so we need it to be at least a little bit slightly bigger. So I'm going to go to this one, and I'm going to make an arch. I have to keep track of what one that is. Go to the other side, hold it down, make the arch from the other side, and there I am. Now I have an intersecting point here between the 2 arches and an intersecting point here between the 2 arches. Put your straight edge right along those 2 intersecting points, and we're going to draw a straight line up to the edges of the circle. So there it is. Now you can see, if you look at it, these are this is all 90-degree angles, right? So now we have 1 point on the circumference, a 2nd point on the circumference, a 3rd point on the circumference, and a 4th point on the circumference. and they would like us to inscribe a square. And something that is inscribed means it's on the inside. So I'm going to line up my ruler between two of the points and draw a straight line. I'm going to move around to the next 2 points, line them up, and draw a straight line. I move around to the next 2 points, line them up, draw my line, and then I move to the last 2 points, line them up, and draw a line. Okay, so now I have my inscribed square inside my circle. So each angle of the square is an inscribed angle. So this is an inscribed angle, this is an inscribed angle, this is an inscribed angle, and this one is an inscribed angle. And they want to know, what is the measure of each angle of the square? Well, this is perpendicular bisector. Perpendicular is always 90 degrees. So for question 4, each angle of the square is going to be the inside angle is going to be 90 degrees. Number 5, notice that within the square are 4 small right triangles. This is a right triangle, this is a right triangle, here's another right triangle, and this one's a right triangle. 2 sides of each small triangle are radii of the circle. So from the center out to here is a radii. From the center out to here is a radii. From the center out to here is a radii. From the center out to here is a radii. Each one of those 4 pieces are radius of the circle. If the radius of the circle is 2 centimeters, so we're saying this is 2 centimeters, then question A asks you, what is the area of each small right triangle? Well, we have to remember, how do we find out area? Area of a triangle equals base times height divided by 2, right? So for A, we've got 2 centimeters times, and the height is also 2 centimeters, divided by 2. So to solve this problem, 2 times 2 is 4 centimeters squared divided by 2, which gives us 2 centimeters squared for the area. This is our answer, 2 centimeters squared. How can we find the area of the inscribed square? So this is letter B. This is the inscribed square around the outside. They want to know how we can find that area. Well, we found out the area of one. Let's say we found out the area of this triangle, and it is 2 centimeters squared. How many triangles do I have? 1, 2, 3, 4. So it's going to be 4 times 2 centimeters squared, which means the area of the whole square is going to be 8 centimeters squared. All right, this next section, we're going to be bisecting an angle. And so the first thing we need to do is just draw an angle. So we're going to start that by putting in an endpoint. And we're going to make a straight line away from the endpoint. And then you can choose any angle you want to make. You can make it skinny. It would probably be better to make it bigger just because you're learning a new skill and you're going to be bisecting the angle. But here I'm going to just draw an angle that looks like that. Nothing fancy. Now, what we're going to do is take your compass, put the circle over the top, the round gold circle over the top of your endpoint, and we're going to choose any point we want to draw an arc. So I'm going to pick the 2 centimeter one, just because that's an easy one to pick. And they've asked us to label this endpoint V, this point right here, R, and this point right here, S. So now we have the vertex and 2 more points, R and S. Now, the next part we have to do a little more carefully. Come over to the S, put the gold circle on top of the endpoint of S. And we're gonna make an arc, but it's gotta be bigger than this distance between these two. So I'm gonna choose, I think 1.5 should do it. So I'm gonna choose and make a partial arc. Then I'm gonna go back over to this side and also choose 1.5. And I'm coming back on that side. Now look, I've made a great big X there. And in X, there is a point right here where the 2 cross, and we're gonna actually call that T. Now you take your ruler, lay your ruler on top of the vertex and the angle T, or the dot T. We're gonna draw our line. This is actually a ray because it has a vertex point and goes out. And now what we have is an angle bisector. Angle bisector. What we said before, this is the angle and a bisector. Well, when we had a segment bisector, that cut it in 2. You can look at this carefully. You could see that your angles should also be cut into 2 exact angles. You have to be very specific with this so that it turns out correctly. So now we have an angle bisector. Question number 6. Use a protractor to measure the original angle you drew and the 2 smaller angles you formed when you constructed the ray. Record all 3 measures. So I don't have a protractor at home. Sorry. So your original angle, you're going to put how many degrees? And then you're going to do angle, let's see, that would be angle, let's do this, angle RVS. And then you would do angle RVT and find out what its degrees is. And then angle TVS. Those are the 3 angles that you're supposed to measure. The original one, the top one, and then the bottom one. And these 2 should be identical. They should be twins. They should be the same. Okay. Now we're going to do something a little more complicated. We're actually going to be drawing a inscribed octagon. So starting with your compass, you're going to make a dot. That's going to be your center. And we're going to put the gold hole over the top of it. You're going to choose a measurement, and I think I'd like this to be a little bigger so you can see it. I'm going to make it 2.5. So here I go. I've got my circle. I'm going to draw in a diameter. So you're going to just try to make it straight, go right across. And now you've got a diameter. We are labeling this M, that's the middle. Over here, this is going to be labeled X. And on this side, it's going to be labeled Z. Now what they want us to do is to make a perpendicular bisector. So now we're practicing what we learned earlier. Take your compass, put the circle right on top of the first point, X. We have to pick something bigger than our diameter, so I'm going to go to 3.5, and I'm going to make a hash mark at 3.5. Move over to the other side, put the gold opening over the Z, find my 3.5 again, and make another arc. All right, now I have this mark and this mark. I'm gonna take my straight edge, line them up right on those, draw my line. I have now made a perpendicular bisector, and we know that that means each of these 4 angles are going to be 90 degrees. But this isn't all they want us to do. Now they want us, we need to label this first. This one will be Y, and it's right here. And the one on the bottom, they don't ask us to label. All right. So now we're going to move forward with the bisectors. This time we're going to bisect these angles. So place your compass over the X. We're going to choose to, let's see, I think I'm going to choose 2.5 here. I'm going to come out here and make a little angle mark. Then I'm going to move my compass over to Y. Hold it down. Find your 2.5 mark. Come back. It has to be on the same mark to make it even. Notice now I have my little wing flaps here. I'm going to line up this part right here with the center mark. And instead of stopping at the center mark, I'm going to go all the way through to the other side to the circumference of the circle. And there I am. Okay, now I have bisected this angle, and I've also bisected this angle. Why does that work? Because anytime you have 2 points on a line, it's a straight line. So we just went through those 2 points. This one here starting at the edge, through this point, and over to the outside edge, and that makes it a straight line. So now we need to do it on the opposite side. So first we're going to go to Y. I'm going to use the 2.5 again. So there's my mark. Then I'm going to come over to Z, and I'm going to do the very same thing at the 2.5 mark. Pull it over so I can see it. There it is. Okay, now I'm going to do the same thing. This is where they match, they come together and intersect. This is where it goes through the hole in the middle, the center part. And now I'm going to start at the circumference, draw through the middle point out to the outside edge of the circumference. And now I have bisected this angle and this angle. And now, if you count them up, 1, 2, 3, 4, 5, 6, 7, 8, I should have 8 equal angles going around the whole circle. I did not answer number 7. Number 7 was on the last paper. Number 7. This was number 6. Number 7 said, why is the ray called an angle bisector? Because it cuts the angle into 2 exactly equal angles. Because it cuts the angle into 2 exactly equal angles. So now we're up to number 8. What is the measure of each small central angle that is formed? Okay, if you're like me, I don't have a protractor at home. So how am I going to figure this out? Well, you could measure it with a protractor, or we think about how many degrees are in a circle. Well, there's 360 degrees in a circle, right? And how many pieces do I have? Well, I have 8. So if I divide 360 by 8, 8 goes into 36 4 times. 4 times 8 is 32. I subtract, I get a 4, bring down my 0. 8 goes into 45 times. 5 times 8 is 40. So each of these angles is going to be 45 degrees. And that makes sense. If you split 90 degrees in half, what's half of 90? Well, it's 45. So each one of these is 45 degrees. And if you add all 8 of them up, you'll get 360. All right, there are 8 points of intersection around the circle. We're going to draw chords from point to point around them till we get a regular octagon. So here we go. We're going to start at Y, come over to this next dot and draw a line. Then we come from this dot to X, draw the line. From X to the next dot, whoop, draw the line. Work your way around the circle, connecting each of the endpoint dots. And there we go. There is our octagon. All right, so now we're up to number 9. Question 9. The octagon is divided into how many congruent triangles? Well, how many do we have? We have 8 congruent triangles. Number 10, segments MW, oops, let's see, I forgot to put in some more. This should be W. Segments MW and MZ, so here's MW and MZ are radii of the same circle. Classify WMZ by its sides. So this side is equal to this side. What kind of triangle is that? Well, sides that are equal, it's isosceles. Isosceles. What is the measure of WMZ? Well, we figured that one out. So number 10, we're going to classify it. It's isosceles. Oh, I can't spell. Oh, well. Number 11. What is the measurement? Well, we figured that one out. It's 45 degrees. What are the measures of MWZ and MZW? Okay, we know this is 45. This is one angle. This is 45. We know that if the sides are equal, these base angles are also equal. So we have to take, for number 12, we have to take 180 degrees because that is the degree measure of a triangle. We're going to subtract 45 because that's the one angle we know. So when we finish subtracting it, we have 135 degrees. And we know that the two base angles are going to be equal, which means that we have to take the 135 degrees and divide it by 2. 2 goes to 13 6 times. 6 times 2 is 12. 2 times 7 is 14. We're going to have 1 left over. So we're going to add another 0, put a decimal point there. So here is our degree measure, 67.5 degrees. All right, we figured that one out. Now for number 13, they ask us, what is the measure of y, w, z? Okay, so how do we know? Well, this measure is going to be exactly the same as this measure because all these triangles are congruent. So this is also going to be 67.5. So we're going to take 67.5, add 67.5. So the measurement from here to here to here, this angle measurement right here, is going to be 135 degrees. Number 14. What is the measure of each inscribed angle formed by the sides of the octagon? Each inscribed angle. We're talking about these angles. That's an inscribed angle. Well, because it is all equal and it's regular, every angle, inscribed angle, is 135 degrees. Okay, we made it through. If you have any questions or you're having trouble with the compass, please feel free to call me. And as you're going through this, if you get confused, stop it, figure out the piece that you need to figure out, and then restart it. That's the good news. All right, see you next time.